Screen is visible. Hello.
Yes, sir.
Yes, sir.
So in the previous class, we have discussed about the Maxwell bridge, Maxwell inductance bridge, and Maxwell inductance capacitance bridge. We have already discussed it. So this is the Maxwell's inductance bridge. Here only inductance we have used here now, L1 and L2. But in the Maxwell inductance bridge, the formula for the unknown resistance and unknown inductance. This is the unknown inductance formula, L1 equal to R3 by R4 into L2 here now. And for the resistance, R1 equal to R2 R3 divided by R4. Actually the formula we know that one, R1 R4 equal to R2 R3. Same thing here in this place. Here one more R2 is added here now. For that reason R2 plus R2 into R3 divided by R4 only we are using. So in the place of R1 here L1 is there here now. See here, and here in the place of R2 it is there L2 here now. So R2 this complete for the inductance. Only here inductance is present, instead of resistance we have to consider L2 here now for the measurement of unknown L1 here. So L1 equal to L2 R3 divided by R4. We can write for the self inductance. So Maxwell inductance bridge. For the Maxwell inductance capacitance bridge, so in this second branch is only kept as non-inductive resistance. Second branch is kept as non-inductive resistance we have kept, but the fourth one we have changed here now. Fourth one we have changed. Roll number 38, are you there?
Yes, sir.
Okay, roll number 28. Just know he has joined.
Yes.
Okay, here the second branch only non-inductive resistance we are using, but the fourth branch is replaced the resistance by some combination of resistance and inductance capacitance we have used here. Combination of resistance and capacitance, both are connected in parallel. Both are connected in parallel here now. So the resistance R4 and C4 are connected in parallel. So for this one, the formula will changes. So according to that, we have yesterday we have discussed these all the things. Yes or no? Discussion kiya na? The previous class. So Z4 equal to R4 and XC4 both are in parallel. So if two resistances are connected in parallel, then R1 R2 is connected in parallel, means R1 into R2 divided by R1 plus R2 we are writing. But here same thing we are writing here now. So XC4 equal to J omega C4 we are going to consider here. So R4 into XC4 equal to 1 by J omega C4. XC equal to 1 by J omega C we will write. Yes or no formula? The formula
Yes,
is, for that reason we are, so by deriving this one here, the J omega C4, this J omega C4 will get cancelled. The R4 term will left as Z4 term will left as R4 divided by 1 plus J omega C4 R4 here now. By splitting this one, connecting here, the R4 I will multiply into here, and this 1 plus J omega C4 R4 I will send into RHS side. It will multiply to the R2 R3 here now. So R1 into R4 plus J omega L1 into R4 equal to R2 R3 into 1, that is called R2 R3, plus R2 R3 into J omega C4 R4 is nothing but J omega R2 R3 C4 R4 we have considered. From this equation, by separating the real term and imaginary part, real part and imaginary part, we'll get L1 and R1 equation here. Now for the real term, what we will do? So R1 R4 equal to R2 R3. Same equation आ गए, R1 R4 equal to R2 R3. Whitson bridge का same equation we got here. R1 R4 equal to R2 R3. Yes or no? So R1 equal to R2 R3 divided by R4 we have considered. For the imaginary part, you consider J omega L1 R4 equal to J omega R2 R3 C4 R4 here. Now J omega get cancelled. L1 you will keep as it is here. Now even R4 also will get cancelled here. Now L1 equal to R2, R3 and C4 here. The left term. R1, R2, sorry, L1 equal to R2, R3 into C4 here now. So you have to remember the equation for the inductance bridge. Maxwell inductance bridge equation is different and Maxwell inductance capacitance bridge is different here now. So by deriving these all the things, we will go for the advantages and some quality factor we have to derive here now. So which is omega L divided by R, we are going to call that one the inductive reactance divided by, it is the ratio of inductive reactance divided by the resistance we are going to call here now. So the quality value is parameter that indicates the quality of an inductor here. इंडक्टर का क्वालिटी चेक करने के लिए इट स्टैंड्स फॉर Q एक्चुअली. Q stands for quality factor here now. So omega L1 divided by R1 we are considering here.